Gas lift, one of the simplest, most flexible and oldest forms of artificial lift. Yet gas lift hides inefficiencies, making it difficult to determine when wells are not operating optimally. Welcome to the next evolution of non-invasive gas lift well surveillance technology, Well Tracer. The biggest challenge facing operators with gas lift wells is the difficulty in determining whether gas is being injected at the optimal point, or whether other points of injection are causing the well to be lifted inefficiently. In the past, there has not been a quick, inexpensive way to determine these kinds of problems, until now. Here's a typical gas lift well operating normally, or so you think. But how do you know for sure? There may be leaks downhole, as you can see here. We naturally assume that all of our gas lift wells are lifting from the bottom valve, since the goal with gas lift is to always lift as deep as possible. But most wells have several valves, some or all of which could be injecting gas. We naturally would like to be sure all our gas lift wells are lifting from the optimal point, but in the past, knowing this for sure has been more art than science. Now with Well Tracer, you can be certain. This patented technology enables you to identify all injection points that are present, the desired injection point as well as any undesired injection points. Well Tracer puts operators squarely in the 21st century by pinpointing your lift depth. Well Tracer operates by placing a small piece of hardware containing a separator and electronics package that measures and verifies any level of CO2. A CO2 gas supply is hooked up to the wellhead on the production casing. Typically, a connection is made at the top of the Christmas tree to sample the production stream. Another connection is made to the injection casing for injecting CO2. Well Tracer's state-of-the-art gas lift analysis and troubleshooting software monitors the CO2 level in real time. Initially, it will indicate the baseline level of CO2 for the well. The CO2 is injected rapidly with enough pressure to overcome the injection pressure. The CO2 slug travels down the casing in a uniform package, indicated here in white. Any place where there is annular communication, the CO2 will follow along with the lift gas. Here we are representing a leak in the tubing. The green is of course the injection lift gas, and the red is the production stream. Well Tracer's real-time monitoring of the CO2 concentration of the well will indicate when any injected CO2 is returned. Where there is no annular communication, the CO2 will pass on by, and the CO2 concentration level at that point will not change. Each place the lift gas and CO2 enters the tubing, such as gas lift valves, a corresponding spike in CO2 levels will be seen at the surface. The days of uncertainty operators once faced trying to determine lift points for gas lift wells is over. With Well Tracer, the future of gas lift wells surveillance and troubleshooting is here.